Good day everyone, welcome back to our YouTube channel. Today we are going to focus on calculus, which is cubic functions. So if you are new to this channel, don't forget to hit subscription button. You can just subscribe on our channel so that you can get notification and on the videos that we shall be posting from time to time. So don't forget to hit subscription button. So our focus today, like I said, is going to be on calculus, which is on cubic functions. So as you can see here, I have just drawn a cubic function for you, which is f of x. So we have f of x, x cubed plus bx squared plus cx plus d. So what we call a cubic function, it's a function in which the highest degree or the highest exponent of the function is 3. That is why we call it a cubic function. So what I have just drawn for you here is one of the functions or one of the graphs on cubic functions. That the cubic function, we call it a cubic function. Why? Because when we draw a graph, the graph must cross the x-intercept 3 times. Or that is to say, the graph has 3 roots in its structure. So that's why we call it a cubic function. So our focus today, our main focus today is not only based on investigating cubic function, but our focus today is going to be on how do we determine what are called stationary points. So first and foremost, before we can determine what are called stationary points, I want us to also understand that you can be given an equation which is of this form, or you can be given a graph which is of this form. So whether you're given a graph or you're given an equation, but let's understand what are called stationary points. Stationary points in this case particularly, we are talking about what are called turning points. So turning points of a cubic function. A cubic function has 2 turning points. It has a turning point here, it has a turning point there. So these 2 turning points, we call them stationary points. So the reason why we call them stationary points is because this is not the most minimum point on the graph, and this is not the most maximum point on the graph. Because the graph continues to go down, it will continue to go down indefinitely. The graph continues to go up on this side, it will continue to go up indefinitely. So the graph will have what are called local maximum. I will denote with an A here. This is called a local maximum. So the graph will also have what is called a local minimum, which I will denote with a B. So this is our local minimum. So in this case, we want to investigate so that we can understand, given a different question, because questions will come in different form. So given a question like this, and you ask it to determine stationary points, what are the steps? What are you expected to do for you to get stationary points? So I want you to pay attention, to pay focus. In this case, we are going to see what steps. I want to give you about 3 steps that you are going to use, that you are going to focus on for you to be able to get what we call stationary points. X and Y value of B, X and Y value of A in this case. So step number 1, I'll call it step 1. So step 1, you need to be able to determine, what is called the derivative of f of x. So the derivative of f of x, in this case, let's find the derivative. The derivative of f of x of the graph of the equation that we are given in this case is going to be 3, drop down 3, x, 3 subtract 1, you get 2, 3x squared. Drop down 2 plus 2, x, 2 minus 1, you get 1. But we don't normally put exponent 1. And then finally minus 16. So this is our derivative of f of x. So once you get your derivative of f of x, the next step that you need to do, which I will just call it step number 2, in this case you have to solve derivative of f of x. That is to make your derivative equals to 0 and solve for x in this case. So let us solve for x. So we now have our derivative. We have 3x squared plus 2x minus 16. Let's make it equals to 0. So once we make it equals to 0, we want to solve. But now if you observe properly, you can see that our derivative is of the highest degree 2. That is to say, our derivative is a squared, so it's a cube, it's a quadratic equation. So in this case, for you to solve for x here, you need to know ways of solving quadratic equations. How do we solve quadratic equation? Quadratic equations are solved by either quadratic formula, or you can solve quadratic equations by using a factorization by inspection or advanced factorization method. So I'll just use advanced factorization method, whereby we're going to drop down factors of 3x squared. In this case, this is 3x and also x, because 3x times x we get 3x squared. And then we also need to know factors of negative 16x. So factors of negative 16x, in this case we have positive 8 and negative 2. 8 times 8 multiplied by negative 2, it will give you negative 16. That's it. So in this case, we now have two pairs. Let's put them in a pair. So this is going to be 3x plus 8, because it's positive. We are going to have another bracket, x minus 2. Then we still make it equals to 0. So in this case, we now have our equation. Our equation has been solved. 3x plus 8. We also have x minus 2. They are equals to 0. So next step is to solve to get the values of x. In this case, 3x plus 8 equals to 0 is going to give us x is going to be equals to negative 8 over 3. The other one, x minus 2 equals to 0, is going to give us x is going to be equals to positive 2. So therefore, at this step, we now have two x values. X is equal to negative 8 over 3. X is equals to 2. So we have only x values in this case. X is negative 8 over 3 and x is equals to 2. So our next step is to now get a corresponding y values for this. Our corresponding y values for this, we are going to substitute. I will call it step number 3. So step number 3, in this case, we are going to substitute. Let us substitute our x values into the cubic function. I will just call it into the original function, which was our cubic function. In this case, this is our cubic function. So when we substitute x is equals to negative 8 over 3, we are going to get corresponding y value. Y is equals to negative 8 over 3 cubed, first one, plus negative 8 over 3 squared, minus 16 negative 8 over 3, then plus 20. So when you substitute into this cubic function, you are going to get a corresponding y value. That means you are going to punch a calculator here. As it is, you are going to get y value, which is equal to 50,6. So if you punch a calculator properly, you are going to see that your answer is going to be 50,6. So once you get your corresponding y value, let us get another corresponding x value, because we're going to we have two values in this case. Let us substitute x is equals to 2. So 2 cubed plus 2 squared, and then minus 16 bracket 2 plus 20. So let us substitute this into the calculator and see what kind of what is the answer, what is the corresponding y value when it becomes 2. So in this case, we're going to get our corresponding y value for this. So once you punch a calculator, you get a corresponding y value. When you get a corresponding y value, you are going to have two values, which is, that is the last step. So you have, when x is negative 8 over 3, y is 50,6, then, and also when x is going to be equals to 2, we are going to have a corresponding y value. Let us determine the corresponding y value with a calculator. So determining the corresponding y value with a calculator is going to give us the value, which is, in this case, let us get we are going to get y is going to be equals to 0. So we now have our corresponding y value. Y is equals to 0.